Today we are going to discuss about design of combined 50. We are going to discuss this with the work example. Let's start the design of combined 40. In this design we have considered some data. The data I have considered I have shown in this figure. Column loads are 400 and 800 service loads, 600 and 1200 ultimate loads. Allowable bearing capacity of soil is 150 kilonewtons per meter square, and the spacings of between columns and column sizes as indicated in this sketch. First, let's calculate the dimension of the footings. We need to calculate dimension. Right. How do we calculate? First, we simplify this sketch. Then it will be easy for us to do the calculation. So, if you mark the distances, we know these distances. Here, 500 and 250. This is 1, 2, 5. So from this above figure we can derive that information. So now first we need to find the load center, geometric center of the load where the resultant will be acting. Right? This is say X. This load 400 SLS. This is 800 SLS. Right? Now we take moment around point A, about this point. Right? We are going to take moment about this point A, then we can write the, say the resultant is R into X equals 400 into 0.125 plus 800 into 5250 plus 125, that is 5375. Here now we know the R. R is the total force act on the footing. X equals this. If you multiply this value become 400 and 350 divided by R. R is 400 plus 800. Right. Then we can find the X as 3.6 meters. Now resultants we know, the distance resultant also we know. If this pressure should be uniform under the footing, we have to get the twice of this distance. Then pressure to be uniform, the length of the footing becomes 3.6 into 2, that is 7.2 meters. Right. Now we know the length of the footing. Now we have to calculate the allowable bearing pressure under the footing. For that we need to consider certain thickness of the footing. Let's say thickness of footing as 600 millimeter. Then the allowable pressure we can calculate. Allowable pressure equals allowable bearing capacity is 150 minus thickness 0.6 into 24. Let's see, consider 24 density of the concrete. This value becomes 135.6 kilonewtons per meter square. Now we know the pressure under the footing. From that we can calculate the width of the footing. How do you calculate the width of the footing? Now we know the total load, we know the length, then width we can calculate. Stress divided by the area, force divided by area equal to stress. So we know the stress and all this. If I write it, stress equal F into A. From this, A equals F divided by stress. Stress here A will be into length into width equal F divided by stress. From this you can get width as F divided by stress into L. Right. Now we can calculate the width of the footing. Force we know. Now 400 plus 800, then it's divided by stress. We calculate the pressure under the footing, 35.6 into length 7.2. From this we get the width of the footing as 1.2 meters. We need to approximate this value during the design. We have to be optimized. Therefore, let's consider the dimension of the footing as 7.2 meter into 1.3 meters. We increase a little bit, and the thickness we already assume as 0.6 meters. Right. These are the dimension of the footings. Now we know the dimension of the footing. Let's do the analysis of the footing. First, you need to calculate the pressure under the footing at the ultimate limit state. For that, we assume the center of gravity or the center of load center is same as we consider for the ULS. Then ULS and SLS load centers are same. Center of gravity same. Right? Then you can calculate the UDL under the footing or under the base as 600 plus 100, 1200. Those are the ultimate loads divided by length is 7.2. From this we get 250 kilonewton per meter. This is the linear load in the footing per meter length. Here we have considered a width 1.3, and for 1.3 meter width section the linear load is 250 kilonewtons per meter. Now let's calculate the bending moment and shear forces. Let's draw the loading arrangements under the footing to calculate the bending moment and the shear forces. So here linear load is there, that is 250 kilonewton per meter. Right? These dimensions of the footing are, now we know already. Let's write 1.825 from the calculations, and this is 5.25. This is 0.125. Right. This load is 600 kilonewton. This will be 1200 kilonewton. Right. Let's say these points are A and C. Now we have to calculate the bending moments. Right. Let's consider distance x from here. So first we calculate the maximum bending moment at point B. Okay, point B, MB. Right. It's simple. Now we know the procedure. M is equal 250 into 1.825 square divided by 2. Right? From this we get 416.3 kilonewton meter. This is for 1.3 meter width. Right? Okay, that we have to keep in mind when you calculate the bending moment. Next, we have to calculate the bending moment between A and B. For that, we have to write an equation. Before writing equation, just draw the loading arrangement. Then it will be easy for us to write the bending moment equation. This is x. Now we know this distance 1.825. This load is 1200. The moment here we are going to calculate, right? So let's try the equation. M equals the load will be in the opposite direction, the same direction, M plus, then we go to the other side, 250 x square by 2 plus 1200 is in the opposite direction, then into x minus 1.825 distance. Right. From this we can write minus 125 x squared plus 1200 x minus 2190. For the maximum bending moment, dm over dx equal 0, right? We have to calculate the dm over dx. First dm over dx from this equation minus, again we have to multiply it by 2 when we derive it. 250 x plus 1200. From this we can get the x as 4.8 meters. Right. Now we know the x. Now we can calculate the maximum bending moment. What's the maximum bending moment? So you can substitute to the equation, right? M equals minus 125 into x squared, that is 4.8 squared divided by 2 plus 1200 x 4.8 minus 1.825. From this we can calculate the m as 690 kilonewton meter. This also for 1.3 meter width. When you calculate the reinforcement area, we can use this. Now we know the bending moment. Now next step is to calculate the shear force. Point B, from this equation we say shear B. Let's see, shear force at point B. Now we are going to calculate shear force point B. So from this side, from C to B, we know the method of calculating shear force. We have 250, then we have to multiply by the distance, then we know the shear force that side. But shear force in that side is not the highest value. Its shear force in the other side will be the highest value. Therefore the VB, maximum shear force, will be equal 1200 minus 250 into 1.825, because it is the highest value, that is 744 kilonewton. Right, we know the bending moment and shear force. Let's draw the bending moment and shear force diagrams first before calculating the. We have point loads like this, right? We have a bending moment here, we have a bending moment here like this, right? Here also we have a P. Here let's go like this, right? This is a very small value. If you calculate, it will be around 2 kilonewton meter. It's negligible because of this edge distance of the column. Here this is 416.3 kilonewton meter. It's also for 1.3 meter width. Shear force, if you consider this segment, now this will be like this, right? We have calculated this value. This is 744 kilonewton, that is the maximum. And this value also we have calculated the bending moment, that is 690 kilonewton meter. Right, now let's calculate the reinforcements. We know the M. Now maximum bending moment and the bending moment at different locations. From that we can calculate the AS. This is possible because this depends on your standard. The reinforcement area calculation will be depend on your standard. Therefore you have to follow that when you calculate in the reinforcement area, right? I am not going to calculate the reinforcement area because it's depend on your particular standard. And also you can substitute that particular equation and you can calculate. Let's see how to calculate the transverse bending moment. That is important. Now your footing will be like this. Let's say consider this column, right? Here the width of the column will be 250, right? We are going to calculate the bending moment here in the transverse direction, face of the column, right? This width we have considered as 1.3 meters, right? Now we have to calculate the transverse bending moment. We can write the equation. M is equals 250, that is per 1.3 meter length, then it will be divided by 1.2 multiplied by the bending moment 1.3 minus 0.25 is the column width, divided by 2 to the distance to the face of the column into half the distance. This is the transverse bending moment. Now if you know the bending moment, you can calculate the reinforcement area for that also. Now let's see how to do the shear designs. There are two types of designs are there, that is punching shear, vertical line shear. We have to check these two type of shears. Right. Now vertical line shear we can calculate from the d distance of the face of the column. Right. So you know the d distance, we have to calculate the effective depth. D is effective depth. Here we have to find the v. Since you know the v here we know already, then you can calculate the this one here. If you will calculate the v there, shear stress can be calculated by v divided by b into d. B you know the width, d is effective depth. From that you have to calculate the v. Now since you have to find the VC or the shear stress or the shear capacity from that relevant equation depending on your standard. VC also have to calculate depending on your standard, and you have to check whether this is okay, otherwise you have to provide the shear links. Now let's see how to calculate the punching shear. Right, punching shear you have to calculate in two different locations. Right, say this is your footing. It's like this. You have to check punching shear at the face of the column and the perimeter, that is punching shear perimeter here. This is 1.5D according to the PS, and this may vary depending on your standard. This may vary. Therefore, you have to consider this value or the punching shear perimeter depending on your standard. Now the vertical line shear, that is punching shear at the face of the column, you can calculate EC, right? That is, you can write equation V shear stress. Now we know the column load 1200 into the 10 to the power 3, that is 4 to convert the units. Now we have 4 sides of the column size is 250. Effective depth that you have to calculate when you do the calculation of reinforcement area, you calculate this. From this you can calculate the shear stress. Now according to British standard, this value should be greater than 0.8 FCU or 5 newtons per millimeter squared, whichever lesser. So our grade is 25, therefore this value become 4 newtons per millimeter square. Therefore our V should be less than 4 newtons per millimeter square. So if you know the D, you can calculate the V that you have to check. Then you have to check the punching shear stress, that's also easy. Now you know that this is the column and this is the perimeter. This is 1.5D. At this perimeter you can calculate the length. You know, since this distance is known, column size is known, this length you can calculate. Then you can calculate the shear force also, and then you can calculate the punching shear. But sometimes it's not applied because when sometimes this punching shear perimeter become outside the column footing, because when you take this distance become outside the footing, then you need not to check the punching shear. You could check the vertical line shear and the shear at the face of the column. Those two are enough. In addition to this, you have to consider the detailing requirements, that is minimum reinforcement, maximum reinforcement, cover to the RF depending on your exposure condition. All that you have to consider, including concrete grade. Those you have to consider during the design. I think today we discuss a lot on design of combined footings, and also I hope that you are aware now the method of calculating the punching shear, vertical line shear, and the bending moments in a combined footing. We didn't go through the method of calculating the reinforcement area because that is depend on your standard. So with that, we are going to end the today lesson. I hope that you will be watching our videos, and let's meet again from new video. Thank you very much.